Millennium to power millennium. Good morning, namaskar. This is Engineer Suraj Singh speaking from Bharat, India on this day, April 18, 2022, Monday, 3:15 a.m. मैं सूरज सिंह सिविल इंजीनियर भारत इंडिया से बोल रहा हूँ। आज दिनांक 18 अप्रैल 2022 सोमवार सुबह के 3:16। Topic is same as usual as we discussed before also. It starts with real quality requirement, and on other end it is what we do to have it. And in between there are involved coordination engineering, projects works, designs contracts, reliable engineers, communication, concrete specifications, civil engineering, safety methods, disputes, etc., etc. It is very significant talk for civil engineers, for other engineers from professional viewpoint. This is my email address, suraj_engineer@yahoo.co.uk. Remember there is underscore also, maybe sometimes it's not visible. suraj_engineer@yahoo.co.uk. And this is my chartered engineer India and international professional engineer and arbitration engineer. This is all right. And that's what it is. I go to next one, and that is arbitration certificate. That is a arbitration engineer certificate, which was awarded to me on April 4th April 2023 recently. My fellow status is here. This certificate is given only to fellows who qualify requirements. And this contracts requirement, arbitration requirements, disputes resolutions mechanism. You understand? Arbitration means statutory title. It is arbitration and engineer because it is from institution of engineers. So you can say it is expertise in field of arbitration and engineering. Arbitration engineer. And here is international professional engineer certificate. That is, you can say on behalf of International Professional Engineers Association, Institution of Engineers India is an authorized body that represents our country India. For this purpose, it maintains register of international professional engineers. On behalf of this body, IPEA for India. This is my civil engineers chartered engineer status, civil engineering division of Institution of Engineers India, and chartered engineer by virtue of my being corporate members. This is qualification preference by virtue of qualification, professional training, and corporate membership. And there's a quality file is will discuss with you, and this coordination file. I'll take also one more file after I close many files. I close this file, and I close this arbitration file now. We will open later on if required, and also I close this file. Alright, now I go to talk about quality issue, that is real quality and real coordination, because we have to accept reality also that without coordination, without quality, we cannot do anything. It's very easy to certify something. Work has been done according to specifications. That is the demand of quality system. But whether it has been done or it has not been done, it can only be signed. But reality is different. Always, sometimes people sign for sake of signing or for sake of record. I am not talking record, I am talking reality. Means quality, real quality, not only in work but in every act, in material selection, in individual selection, in machine selection, in activity selection. Means there should be everything that must be oriented on quality, and that is reason I call it real quality. And coordination is a process. It's not simply saying that it's coordination. Coordination is very powerful if you want to do right job in right time. Coordination is strong engineering, you can say. It is concentrated engineering. It's not simply superficial one or you can say randomly you can take it. Coordination is very important part in life. Coordination, particularly in engineering and technical works, is very important. Coordination is not a word itself, it's complete engineering. Engineering means it is kind of super process. If we miss this process, we can miss everything. Therefore, I have linked both, I have clubbed both quality and coordination, and with this club, I have also extended my clubbing to communication. Communication means communication links to coordination, and coordination links to quality, and quality links to product. This like that. And coordination and communication and all this, these are all used in designs as well as in works execution. It has direct relation, because if work is not done, then there exists no meaning of quality, no meaning of coordination, no meaning of all this if work is not done. That's why work is important. We know work has to be done, and that it has to be done pointedly, it has to be done sequentially, it has to be done like a complete system. And system means every organ of that system. System means every method which we decide about carrying out any activity, whatever activity, that must be done according to our plans or procedures. There should be no miss. And what happens at what time, even up to time limits, we can decide if we have that capacity. Within this minute, this shall be done. It's like that. So coordination is something that doesn't come from any book. It comes from experience. It comes from real working. Maybe you don't have any professional degree in terms of coordination, but you know without coordination you cannot do anything. Without coordination we cannot even think, we cannot even analyze. Analysis means analysis is also based on information. It's also based on mental capacity. It's based on what level of learning one has got. And that's a real requirement, real procedure. We have to concentrate on everything to know to do something. And really, it's sometimes I can say it's a kind of innovative work to some extent, because coordination means you have to carry out work in sequence. You cannot miss sequence, and if sequence cannot be missed, it's a kind of concentration. You can decide concentration in advance that these activities shall be done, and that's very important point. These activities shall be done, and we have to do those activities. Those points cannot be interfered with, and that's what I say. Real quality and real coordination are very important factors. We cannot go without that. And everyone who sleeps must be awakened. Why we are sleeping? We cannot sleep if we don't have quality, if we don't do right work. If suppose something is not done and you think that's urgent, but you want to take rest, it's your problem. It shall never be done. Real quality and real coordination, it's for everyone. It's on individual basis. I think it's very important. If you as an individual, I think of I have to do this is requirement, and individually if I take care, I can control, or you can control whatever you want. Maybe beginning is always difficult. Beginning of every activity is difficult, but it doesn't matter. Once you start means automatically other activities will follow up. That's why starting is always trouble. And those who can start successfully, automatically they find another. Even if you sometimes do not understand what to do next, coordination system shall tell you what you have to do next. Work shall automatically speak to you silently. This is what you have to do. And that's where sequence moves on. Coordination itself will bring another point together, or it tells you this is a requirement. Which point you have to select, you can elect yourself. And this is a part of communication. You have to communicate to yourself, you have to communicate to what information you have to communicate to get more information, through whatever source, and that's what communication plays a very significant role. To an extent, coordination is concerned, and coordination plays very important role. To an extent, quality is concerned, and quality is also very responsible. Quality refers to us. Yes, it has been done or it has to be done. And if that is done, product becomes quality one. We can say this product is quality rich, or whatever quality is indicated for this, that quality has been achieved. And that's where every individual is also a product. When we pass engineering, to what level we have achieved our knowledge, what level the certification is, okay, fine, that's one part of that, which declares that this field has been passed by this person. But it doesn't tell what level. You may say he got some marks, one got some marks, some percentages. That is one part of that. But when you work same what you learn, it's very difficult in beginning, because you don't have clear concept what to work, and that clear concept itself you have to learn and feel. You have to think on and learn. You have to do one job, the next job, or you have to interact with your friends, your colleagues, your peers, or your workers to know more about their experience, and you can decide, okay, fine, this work can be done this way, and that's where we can say how world moves. And, learning is very important from every viewpoint, and we cannot say no, we have to accept this. And that is why I think that there must be certain domains, and that domain, since quality domain, which is a delivery itself, a product, so you can see we are taking from delivery, and then how this delivery is done. This delivery is done because of work, and because of work, and you can say work has been done because of coordination, because work has been done because of coordination, and that is very important point, coordination point. So I have written here two domains. One is quality domain, other one is coordination domain. And coordination includes communication, and quality includes product. It's like that. Quality cannot be done without product. It has to be applied on product, and product means quality product. And coordination cannot be done without communication, and without required technology, or without required interlinked technology. And that's very important. It's not one product alone. There can be links to other products, and that's why I'm saying, for example, concrete product. If you take concrete, cannot be linked directly. It has got so many ingredients with that. Similarly, it has got composition with steel bars. Likewise, every material has same. Just like with the finishing items, we take mortar with that, or we take styling glue with that. Likewise, every product has some relations, some interrelations with other products, and that is why you can say quality and coordination are interlinked. So we have to understand these points ourselves. This paper which I write doesn't mean I to speak same. I'm just trying to let you know what I think about. And most important, I would say that individual is very important element. Individual means every individual, every worker, every technician, every supervisor, every individual, or whoever is designer, whoever is site person, who is factory person. Every individual must contribute to all this. Maybe they cannot contribute according to documentation, but experience. If you learn something not right, then you will not do that right. That's why it's very important in beginning on job training that people should know. Particularly those who are non-civil, they should know. They are better, I think, as far as controls are concerned. They can be better because they work indoors and they don't depend on many factors. Something is decided, material is built, processing is done, and the controls if it is done. These people use generally materials which are delivered. But when quality issues come, quality applies everywhere. Means I don't find quality is working very well everywhere. It's not working very well. We may say we are working quality. So systems working doesn't mean quality delivery. System itself says, yeah, you decide yourself according to certain guidelines how you have to work, and then that work should deliver good product. But it doesn't happen automatically, because there are equipment, there are machines involved, and there are individuals involved. And everybody has to understand this duty. Carelessness is very bad element in work. If people are ignorant, they are careless, they take it easily, and mistakes are done. Of course, information is not applied in right time, and that's why we can say. But engineers, as far as they are concerned, they can handle very conveniently both quality and coordination without any problem. And we can say engineers can handle both domains successfully without without facing any problem, or even if they face problems, they can encounter problems and solve it. And that's what we say, that we have to establish both domains permanently with us. An individual must have both domains, individual engineer, foreman, or general, or whosoever is there, or even worker. I consider workers self, to some extent, self-supervisor. Supervisor cannot stand with worker all times, and therefore it is responsibility of every worker to be sure first of all how job shall be done or should be done, and do honestly and sincerely, because you are worker, you are also responsible. You cannot simply say stand with me all times, supervise, and only then I can work. Work is work, and you may do your work, otherwise. So this individual approach. Individual approach is very important, and that's why I give first consideration to human resources individuals who are responsible for work, and they should first understand what is requirement. Without requirement, you can say, you cannot simply say, just blindly doing something doesn't mean anything. You should have confidence in you. Okay, by virtue of experience you should have confidence, or by virtue of training you should have confidence. Whatever confidence level you have, that's very important point in engineering, construction, processing, everywhere. And that's why we can say reliable coordination, engineering projects, public engineers, etc. It's very important. I'm saying public and engineers, because the engineers are also part of public. And public, you work for people, you work for public at international level or at national level. But I'm talking about first national level, because we have to give quality. If we don't give quality, nobody shall buy our products. Just a name can be sold once, not twice even. I have seen people don't have quality, but they have certificates, and that's not requirement of quality. Okay, certificates should be there for purpose of reference, for purpose of, you can say, evidence that yes, you follow this system. But that doesn't mean you blindly do that. We have to understand these points very well. How can we do reliable coordination engineering projects, and we have to understand all these points clearly. You may be thinking every day I talk same and repeat same. I just to tell you that I don't feel bored, and you should not feel bored, because work is always bored. You have to convert boring to entertainment yourself, because we believe in mind and we live in mind. Engineers live in mind, intellectuals live in mind. Without mind they cannot sleep. It's not like others who don't have mind, and they can do whatever they want. But as far as professionals are concerned, intellectuals are concerned, first requirement of quality is that you should be happy with work. That's first requirement, because if you're not happy with work, you don't like work, there's no way you can perform that work. Work is done using your mental capacity as well as your conscience, as well as your acceptance of that. And that acceptance must be converted to happiness, because it's always serious. Means if suppose you have to find 10 information for an item, you have to reach those information first where are they available. And if you don't find them, then you cannot do what you intended to do, or what you plan to do. And therefore I can say this is a very important point. Is good engineering, in fact communication support is always there, and these projects I am trying to show you, a lot of communication were done on these projects, otherwise there was no meaning. And then I'll go to some kind of writing on this. Let me see if I can show you some kind of writing, because something direction is also very important. Without direction nothing is possible. I'm not showing complete details of this, I'm just trying to tell some notes which I made last time, long I discussed with you, and it is better to have some repetition sometimes, so that people get it in that. And that's a very important point we concerned with. And now many projects are here. Some only now what to say coordination engineering is a must, and that's what I say. Without this, we cannot even survive. It's coordination. Engineering is a must on every project. That's what is talked about. Designs, it may be designs, construction, controls. These are very absolutely interrelated required sections to achieve from successful start to completion of a project. All must be applicable throughout project stages with all works be smoothly affected. These sections or stages are initial conceptual designs, designing for works execution procedure implementation about how to chart out construction of design project works, project construction works, currency decisions and works carrying out, testing, completion and commissioning, and launching use of project. When project title terminates, renaming title, operation or occupation in place of project. These are requirements. What we say about coordination engineering, we should know we have to done designs or we have to done construction, and we have to apply controls on both. Even if you do design cannot be done just by your imagination. Yes, you can imagine, you can conceive, but ultimately we have to apply our knowledge on that conception. How to transform my mind's conception to paper, and then how to use my knowledge on subjects to do designs. Designs is a very long process. Of course, it's mental exercise as well as physical. Physical in a sense of working, and it's not physical in the sense of exercises. This means your mind should pick up all these, and you should know what was your final design should be, and then you have to justify that design, which is justified by calculation of stresses in various members and sections, and to justify also that these are safe for this. This means analysis is done for every part of work, and designs is very important part, because without designs we cannot do anything, we cannot construct anything, we cannot do any factory work or processing work or whatsoever. So design means if designs are delivered professionally in best way, depending upon including in calculations that this metal may be replaced or this may not be replaced, this metal may be available, this may not be available. We should know this information also. We should find this information also. Why doing design work? Because design ultimately goes to construction, and that is very important field. Construction, widest field. Widest field, and design is because construction is based on design. Design is also super. You can say one should have super understanding of this. Otherwise, there is nothing as such. You can say design is important. And you can say work is also very important, and both are based on something. We have to understand that something. Otherwise, there is no difference between a person who has got no knowledge and a person who is intellectual in that field, in that professional work. So construction and designs are very much interrelated. Even if we try to avoid this, there's no way we can avoid. And as I said, that every individual should be a quality person. Every individual should, by practice and by extraction of knowledge, involve itself in best. It's not only measurement alone, it is measurement accuracy as well as product designs, result to its being done, how it is done, how powerful it is. Means we have to do test for every material, and that's the way to satisfy ourselves with that test. A system should satisfy itself that you have done controls, and test means controls, nothing else. And these controls are very important from every point of view, and that's why I say whether or not your drawing is right or not, and that's also to some extent you have to accept. Maybe some errors available on drawings, but that can be corrected, and that common sense everybody has, because we are experienced people, and without experience there is no meaning of studies. If you don't study, if I study building, this is building, learning how to do building, we learn designs, we learn everything, we learn. But while we go to field, we have to apply that. It may be called something, whatever, internship or whatever, that's different way. I am saying self-learning is very important. We have to learn self, and that's also a part of quality. That person doesn't go to everybody all the time to get information. That person tries to say or work out that and submit for approval. I think that's also best way of practice. We have to think ourselves, and that's why I say these sections of stages now. Designs may be considered or safe or safe both way, and optimum otherwise. And construction involves actual expenses, it involves time, and it involves finances and liabilities, and buildings professional reputation, all must be cared for, and that's very important point. We cannot leave that behind. We have to understand both all this, and that's come what may, there can be no excuse, acceptable excuse. We cannot accept anything. Oh no, there was some error, that's why I give you concession. Why did you cause error? That is a question mark. If you caused because of you did not have information, or you did not understand that information, or because you did not care for that, and you just do this job, don't without care, avoiding care of that, and that's very important point. Work's quality cannot be compromised, and therefore we do not intend to compromise that. That's a important point. So we can say, yeah, also only simply explanation of how system we do. We have direction to do systems, but systems do not move us. We move systems. Systems do not reach us. We have to devise system. It is experienced people in engineering who can devise the systems related to engineering, and that's very important part. We have to learn that also in each and every respect. Otherwise, it is very very difficult. We cannot say we can do it. We cannot do it. We have to do it professionally, and that's very important part of life. We have to do it professionally. We have to do it. We have to. We have to think of now placing of concrete, which is a very important one. We have to think this also in every way. We have to understand in every way. Only then we can find some answer to this placing of concrete. It's very important point. placing of concrete is a very important part in engineering and construction, particularly because without concrete we cannot do anything, and concrete is not that easy. Concrete is very complex technology, we should know that. It's not non clearly to everybody. People who are in field, people on designs, maybe everybody is not clear about what is requirement and temperature controls, aggregate controls, structural controls, metal controls. Placing is one part. Placing is very important part. It's very important part, you can say, because placing is final one. How you place concrete, it's very important from every viewpoint, because after placing nothing can be done except curing. And curing means curing has no option. It's just an activity. It cannot change concrete, whatever you laid, that shape can't be changed, that quality can't be changed. It's just an application, but important and significant applications, because without curing concrete cannot live, it shall die. And that point is very important. We have to understand that. And that's why placing, first we have manufactured it, we have mixed it, we transport it from mixing plant to site, and then on site we unload this concrete through pump or through crane, and that is different transportation from transit mixer or from mixer to location where it has to be laid. So there are two kind of transportations. One is mixing originally at plant or site located plant or whatever plant, wherever it is, long distance plant, not too far. This is transportation through transit mixer or concrete mixer. That is first transport, and then where we receive it on site, we take it out from transit mixer and pour into either crane bucket or you can say pump, whatever way. Both transportations, and the second leads to placing because it's transported to location. And once it is done, compaction is done, there is no other way we can change it, no other way. And that's why placing concrete is very significant. It's same as it was significant during mixing. And during transport we can't do anything, but during placing we can take complete controls, and that's why it's a very significant point. We can say it's just some refreshing, but refreshing is also very important, because we try to know better when you do second reading, and in areas where water absorption is expected, we have to think that point. In areas where water absorption is expected, such as on ground or in formwork, areas shall be saturated with water prior to placing. That is first requirement. Furthermore, when temperature of formwork or reinforcement is anticipated to rise substantially due to direct exposure to sunlight, appropriate measures such as water sprinkling or covering shall be taken. Concrete placing shall be completed as promptly as possible, and elapsed time, whatever time, from start of mixing to placing, completion of placing should not exceed 1.5 hours, and that's very important point. And also we have to consider temperature, which is very much responsible for concrete in every way. Temperature of concrete at time of placing shall not exceed 35 degrees, though it should be 32 according to some specifications, but at maximum it is 35 degrees Celsius, not more than that. Furthermore, during construction, temperatures of concrete and surrounding atmosphere shall be periodically measured, and plan for construction may be changed accordingly if required. So we have to understand 35 is maximum, though it is 32, and minimum is 5 or 4 degrees Celsius for normal concreting operation. And when placing concrete in high temperature conditions, areas such as the ground and formwork may easily dry out. In that case, drying process affects flowability of concrete, and flowability of concrete is affected by absorbing concrete water. Therefore, I think it's necessary to saturate these portions with water before concreting. This is dry surfaces, or whatever heat it is better to saturate these surfaces by water before we place concrete. Formwork temperature, reinforcing bar temperature may rise substantially under direct exposure to sunlight, which results in quick setting of concrete. Quick setting of concrete is not acceptable. Quick setting of concrete and adversely that affects the quality of hardened concrete. Covering or sprinkling should be carried out to keep formwork and reinforcing bars at low temperature. This covering or sprinkling should be carried out to keep formwork and reinforcing bars at low temperature. It is therefore necessary, however, to avoid excessive watering, so that water should not be stagnant, and water is not left out in formwork, to observe conditions in formwork and remove that water before concrete is placed on that. That point is very good. Water can be stagnant in formwork only. Water can't be stagnant on steel reinforcement, and that point we have to really understand clearly, and that's what practically we know. And also slump has relation. Slump of hot weather concreting. Slump of hot weather concreting is highly susceptible. Slump of hot weather concreting is highly susceptible to decreases over time. Now, consequently, concrete that has been left unplaced after being mixed may become more difficult to place. Slump has relation to placement, and in hot weather conditions, hot weathers, you can say slump shall decrease naturally as time passes, and result would be concrete that has been left unplaced after being mixed may become difficult to place or difficult to handle. And this happens, what to do in construction during a period when outdoor air temperature is higher than 25 degrees Celsius. It is expected, what to do when temperature is so much expected. Check time dependent changeability of concrete in advance to that's required minimum slump for placement may be according to section can be met. In general, slump at matching plants, slump during transport to site, and then further slump from transport to site to transport to location. We expect that slump to be within limits when it is placed. And for that we have to see what slump we have to use at matching plant and how much time it shall take. So that's why it's said that 1.5 hours is generally acceptable. Also, it depends on temperature. In general, amount of decrease in slump is small for 1.5 hours after completion of mixing and concrete. Mixing and concrete can be placed without causing any problem. During that period, since such changes in quality tend to increase as air temperature rises, it's desirable that concrete be placed continuously and as quickly as possible so as not to cause problems such as cold joints. There's a table which allows placement intervals and that we can follow. Outside air temperature when exceeds 25 degrees is 2 hours. Likewise or less, it is desirable in case of hot weather environment, hot weather conditions, that shorter placement interval be specified in order to prevent occurrence of cold joints. And cold joints are not acceptable, we know very well. Temperature of concrete placing time shall be as low as possible in order to prevent adverse effects. Temperature of concrete placing time shall be as low as possible. Better it is lower. Upper limit of concrete temperature at placing time has been determined to be lower than 35 degrees Celsius. Generally, as I said, it should be 32. based on whatever reasons, and reasons being temperature is lower. When temperature is lower than 30 degrees Celsius, adverse effects of temperature on concrete quality is relatively small if temperature is less than 30 degrees Celsius. It says less than 30. Adverse effect of temperature on concrete quality is relatively small. Under hot weather conditions, it has been observed that temperature of ready-mix concrete at point of discharge is between 30 to 33 degrees Celsius. Temperature of ready-mix concrete at point of discharge should be 30 to 30 degrees Celsius, and this temperature rise approximately 2 degrees Celsius during transportation of concrete to site. With currently available facilities, it is difficult for concrete plants to cool down concrete materials before mixing. If concrete quality can be assured, required concrete quality can be assured if concrete temperature is kept between 30 to 35 degrees Celsius. That's why it says 32 degrees Celsius. Now, by using a retarding agent, by using a retarding agent, or by rapid construction, when development of thermal crack is anticipated, verification of thermal cracking shall be carried out and concrete placing temperature determined. When development of thermal cracking is anticipated, verification of thermal cracking shall be carried out and concrete placing temperature determined. In hot weather conditions, concreting, temperature of materials and concrete should be measured. Temperature of materials and concrete should be measured. If predicted placing temperature or actual measured concrete temperature exceeds plant temperature, if predicted placing temperature or actual measured concrete temperature exceed plant temperature, construction plan shall be modified and appropriate construction method selected based on measured temperatures of materials and concrete. Now we come to curing, because let us say placing has been done rightly, and once it is done, you cannot change it at all, because this is either you have to destruct material, you have to remove all material, or whatever you did, that's permanent. You cannot change it. It may live for 50 years, it may live for 100 years, depending on what requirement it is. Then you can say it's permanent material and you have no control after that except curing controls, nothing else. Once you have finished it, you have no control on that. Only control is, even finishing does not give anything, because it's just surface finish. It's not called quantity finish or what. Placement, in fact, is final shape. Curing shall be started immediately, and there should be no delay at all. Curing shall be started immediately after placing concrete, so that concrete surface can be protected from drying. Appropriate measures shall be taken to protect concrete against direct sunlight and wind, so that cracks due to rapid drying can be avoided. Curing shall be started immediately after placing concrete, so that concrete surface can be protected from drying. Appropriate measures to be taken to protect concrete against direct sunlight and wind, so that cracks due to rapid drying can be avoided. And that's important part, and we have to think of what else can we do. Surface of concrete placed under hot weather dries up. Surface of concrete placed under hot weather. Surface of concrete placed under hot weather dries up quickly. Surface of concrete placed under hot weather dries up quickly when exposed direct to sunlight or wind, so that concrete becomes difficult to finish. That's right. In hot weather conditions, surface dries very well, you can say, and due to wind also, hot wind, concrete becomes difficult to finish. Finishing also becomes a problem, and potential for crack formation increases. Placed concrete should be cured at an earliest, so that surface does not dry out. We have to protect surface. Moist curing can be decided. Moist curing period shall be decided in accordance with provisions. And in case a wooden formwork is used, it shall be kept in a saturated condition during curing period, since this formwork is likely to dry out. Means if you use wooden planks or wooden plywood, you use timber, and you should keep cured even during finishing time by moist, by whatever way. You cannot permit evaporation of hydration. They have to keep that water contents. Curing is very important during placing. Means when you can do it, you can spray either curing compound, or you can keep surface covered or with saturated whatever Asian bags. Exposed concrete surface should also be kept in saturated conditions. Exposed concrete surfaces should also be kept in saturated conditions during curing period. That is, exposed concrete surface should also be kept in saturated condition during curing period after formwork is removed. Those surfaces where you remove formwork, that's called exposed surfaces. Especially in case of high temperature or low humidity, cracking is likely to occur. High temperature and low humidity, cracking is likely to occur due to rapid drying, because humidity is also low. It will dry rapidly. We have to compensate, and that's why we say in case of high temperature and low humidity, cracking is likely to occur due to rapid drying. Measures such as sprinkling or covering should be conducted in order to prevent surface from drying. For structures with wide surface areas like slabs or suspended slabs where sprinkling or covering is difficult, membrane curing may be applied in accordance with regulations stipulated. Membrane curing agent should be of type which absorbs only little thermal energy from direct sunlight. If cracking due to rapid drying of surface is recognized while concrete has not hardened, after placing, revibrating or tamping, should be conducted to eliminate cracking. Means revibrate after it's not hardened yet. If you can revibrate, or tamping should be conducted. Tamping is easy, I think it's not a problem. Then we have to see mass concrete. We are just refreshing in cases. You can say, what is mass concrete? That's a question mark. You can understand from experience only, otherwise there's no hard and fast definitions, because mass concrete where temperature generation is very high within volume of concrete itself. In case where thermal stress due to heat generated by hydration of cement is problematic, concrete is regarded as mass concrete. It says when thermal stress due to heat generated by hydration of cement is problematic, concrete is regarded as a mass concrete, and measures to be taken shall be carefully determined. For mass concrete, verification concerning thermal stress and thermal cracking due to heat generated by hydration of cement shall be performed. For mass concrete, verification concerning thermal stress and thermal cracking due to heat generated by hydration of cement shall be performed in advance in accordance with design general requirements. It shall be ascertained prior to commencement of construction that conditions assumed in design section of the specification agree with actual construction conditions. It shall be ascertained prior to commencement of construction that conditions assumed in design section of this specification agree with actual construction conditions. If conditions assumed in design section do not agree with the actual construction conditions, verification concerning thermal stress and thermal cracking due to heat generated by hydration of cement shall be performed prior to commencement of construction. Means it shall be ascertained prior to commencement of construction that conditions assumed in design sections of this specification agree with actual construction conditions. If that doesn't work, then it is to be assumed design section do not agree with conditions, their verification concerning thermal stress and thermal cracking due to heat generation by hydration of cement shall be performed prior to commencement of construction. Prior to massive concrete construction, appropriate plans for concrete temperature, control, transportation or placement, curing, etc. shall be made so that effects of thermal crack control measures determined in advance can be achieved. Together with recent developments, this is all theoretical we are talking here. It's development, and that's the point we have concern with. And that is together with developments in advanced construction methodology or methods, there have been increasing demand for construction of large size concrete. There's been increased demand for construction large size elements, you can say, large size structures. And observe that thermal stress which develops due to temperature variation during cement hydration process, it causes thermal cracking of large size concrete structures, or we can call them massive structures. These problems were once considered peculiar to concrete dams or concrete structures with especially large size members. However, harmful cracks are often recognized even in relatively small sized structures, depending on cement materials used in construction conditions. Concrete structures which face above these problems, you may say of big blocks, massive blocks which face above problems of temperature controls, thermal stress due to heat of hydration, shall be dealt with as mass concrete, and consequently spatial considerations are necessary. It can be absolutely determined due to fluctuation of type of structure. Materials used in construction conditions, size of member regarded as mass concrete is roughly considered to be not less than 80 to 100, or say 800 to 1000 mm in thickness minimum. If we have to think of mass concrete, or you can say thick member, not thin member, up to 800 mm size, you can say it is thin member, let us say. So if it is 800 mm, it comes into category of thick member, or also a kind of mass. This dimension of minimum size 800 to, let's assume 800, don't be mixed up, in thickness for wide slab, or to be not less than 500 mm for slab. You can say not less than 500 for walls. Walls 500 mm thick means walls of a big reservoir, that can be considered, not keep 800 mm but 500 mm. So that is also considered thick member or mass member. Restrained at lower end, it says for walls restrained at lower end, And for concrete with rich mixed proportions, as in case of precast concrete structures, thin members may also be included in scope of this chapter, this talk. Even if precast concrete is concerned thick, not don't wait for 500 or 800, but lesser one can also be considered as mass member. So for concrete with rich mixed proportions, as in case of precast concrete structures, thin members may also be included in scope of this chapter. Depending on the restraining conditions, a dam concrete is not stipulated in this chapter, but in standard specifications, and the crack controlling measures such as crack prevention or restriction of crack provision, means how to control crack, that we have discussed inside crack controlling measures such as crack prevention or restriction of crack positions and width should be taken to each stage of design. Selection of materials, determination of mix proportions, and construction. Method for evaluating effectiveness of each crack controlling countermeasures. Evaluating effectiveness of each crack controlling countermeasures by quantitatively estimating influence of these measures on development of thermal crack at various stages. It has been almost established from recent studies the verification of thermal crack in construction of massive concrete should be carried out in advance, which stipulates verification methods for thermal stress and thermal crack caused by heat of hydration. Heat of hydration can cause thermal cracks. In that concrete world of mass concrete, where large amount of concrete is used continuously in order to satisfy desired concrete quality, it is especially important that processes of production, supply, transportation, and compaction of concrete are controlled completely based on construction plans. During construction of mass concrete structures, concrete may be delivered from several ready-mix concrete plants, which result, because we use many plants. What is rule then? Cement and chemical admixture produced by same manufacturer, coarse and fine aggregates produced from same region should be used when possible. When metals differ for each ready-mix concrete plant, trial mixing should be carried out in advance in order to confirm safeness of mixing before construction. When using chemical mixture, great attention is required because incompatibility between chemical admixtures may be observed. Now, design section specifically requires a general rule: verification of performed concerning initial cracking. Now, it also requires that the limit of crack width be set if cracking is to be prevented or permitted. Design section assumes construction conditions for purpose of design studies. Actual construction conditions such as weather condition, which is air temperature or wind, may change considerably. Prior to commencement of construction, it must be checked whether pre-assumed conditions agree with actual construction conditions. If pre-assumed conditions have turned out to differ from actual construction conditions, study results based on design section required to be modified. Studies must be conducted again before starting construction by method specified in design section of the specification on basis of actual construction conditions. In controlling thermal cracking during mass concrete construction, various measures for preventing cracking, controlling position, interval and width of cracks shall be carried out at construction stage in order to satisfy required function and performance of structure. How to control thermal cracking? During mass concrete construction, we have to take various measures to prevent cracking and control position, of course, interval and width of crack. We have to make sure it should be carried out at construction stage itself in order to satisfy the required function and performance of structure. In order to control thermal cracking, not only selection of cement type, materials, admixtures, mixed proportions, as well as adjustment of concrete placing requirements. Also selection of formwork dimension, lift height, joint position, placing time interval, material and fabrication of formwork, as well as curing method should be considered thoroughly from production to construction stages. Depending on structure type, controlling crack position by crack inducing joint may be effective in some cases. Regarding these measures in making concrete and construction for controlling and preventing cracking, construction of mass concrete should in general be carried out in accordance with standard specifications. Design in which requirements on material, mix, proportion, production and construction methods are described in details based on prior examination related to thermal cracking. Other methods for controlling or preventing thermal cracking, such as using pipes cooling for dam concrete or large bridge piers, using expensive concrete or arranging reinforcing bars for crack control can be adopted. However, since these methods lead to cost rise, technical and economical efficiencies should be evaluated. This was about that. Now we come to materials. As a general rule, cement admixtures used in mass concrete should be one specified in design. If cement or admixtures mentioned are to be used, verification concerning thermal stress and thermal cracking due to heat generated by addition of cement shall be performed. Cement and admixtures used in mass concrete must be selected after verification concerning thermal stress and thermal cracking due to heat generated by the addition of cement. Now, cement is selected on basis of verification concerning thermal stress and thermal cracking. So, however, actual construction conditions cannot always be predicted at design stage. There may be cases where prior to commencement of construction, cement and other metals are reconsidered and selected again through similar verification. In case of mass concrete, quality of cement greatly affects strength of concrete. Signals, again, big problem. I just checked. These are intolerable now. 0, 0, 0, 0. And I don't believe now. It was good till now, but now status has come. Something has come. Let us see how long it works. I can't say anything, can't predict anything as far as this is concerned. In case of mass concrete, In case of mass concrete, quality of cement greatly affects the strength of concrete. Heat generated by hydration when selecting cement to be used in mass concrete or major concrete, you can say massive block concrete. It is necessary to thoroughly study characters of different type of cement and select cement appropriately so that concrete of required quality can be obtained. In general, it is desirable that low heat cement such as moderate heat Portland cement, low heat Portland cement, blast furnace slag cement and fly ash cement be used. When selecting cement, it should be kept in mind that generation of heat by blast furnace slag cement tends to be accelerated as temperature rises. It should be kept in mind that generation of heat by blast furnace slag cement tends to be accelerated as temperature rises. In case where blended cement made by mixing Portland cement with relatively large quantities of admixtures such as ground, granulated blast furnace slag and fly ash is used, quality and properties of such blended cement often vary considerably among manufacturers. When using such cement, it is necessary to fully identify its quality and properties in advance. Conducting tests. In general, case of cement whose heat generation is suppressed, degree of long-term strength increases relatively high. In general, in case of cement whose heat generation is suppressed, degree of long-term strength increase is relatively high. Compared with normal potted cement, when using such cement, it is good practice to check stresses that occur in member during period until specified strength is reached, and use a relatively old age around 91 days say as a reference age at which specified strength is determined. Admixtures commonly used for mass concrete include mineral admixtures such as fly ash and ground granulated blast furnace slag GGBS, and chemical admixtures such as air entraining agents, water reducing agents. So there are three. One is air entraining agent, one is water reducing agent, and one is air entraining water reducing agents, and air entraining high range water reducing agents. Use of expensive admixtures. Use of expensive admixtures has been increased in recent times. Use of high quality fly ash brings about a number of beneficial effects. Use of high quality fly ash brings about a number of beneficial effects such as improving workability of concrete. That is, if you use high quality fly ash, you can improve workability of concrete, reducing water content, increasing old age strength development, and reducing temperature rise due to heat of hydration of concrete. Fly ash therefore is advantageous for purpose of controlling occurrence of cracking due to thermal stress. Furthermore, appropriate use of fine grained blast furnace slag powder mix makes it possible not only to increase long-term strength of concrete but also to slow down generation of heat due to hydration. Furthermore, appropriate use of fine grained blast furnace slag powder makes it possible not only to increase long-term strength of concrete but also to slow down generation of heat due to hydration. That is, furthermore, appropriate use of fine-grained blast furnaces like powder makes it possible not only to increase long-term strength of concrete, but also to slow down generation of heat due to hydration. Appropriate use of air entering agent, water reducing agent, air entering water reducing agent, and air entering high range water reducing agent makes it possible to improve workability of concrete, reduce water content, and thereby reduce cement content. By using these chemical mixtures and mixtures, amount of rise in concrete temperature can be reduced. If a large volume of mass concrete is to be placed, it is recommended that retarded type water reducing of air entering water reducing agents can be used to lower. If a large volume of mass concrete is to be placed, it is recommended that retarded type water reducing agent or air entering water reducing agent be used to lower rate of generation of heat of hydration and prevent occurrence of cold joints. In such cases, however, setting may be retarded considerably depending on such factors as combination of mineral admixtures to be used in air temperature during concrete construction. Therefore, important to check in advance on degree of retardation of concrete setting and influence on strength development. If a large number of mass concretes to be placed, it is recommended that earlier that retarded type water reducing agents or air entering water reducing agents be used to lower rate of generation of heat of hydration and prevent occurrence of cold joints. That is, retarded type water reducing agents and air entering water reducing agents be used to lower rate of generation of heat of hydration and prevent occurrence of cold joints. In such cases, however, setting may be retarded considerably. Depending on such factors as its combination with mineral admixtures to be used and air temperature during construction. It's therefore important to check in on degree of retardation of concrete setting and influence on strength development characteristics by means of tests. Mixed proportions. Basic rules: cement content of mass concrete should be as specified in design. It's not possible to achieve required workability, strength, durability, water tightness, cracking resistance, or steel protection performance with cement content specified at design stage, or if type of cement or admixture be used has been changed. Verification concerning thermal stress and thermal cracking shall be conducted again, and cement content accordingly. Rate of heat generation of concrete is roughly proportional to cement content. In general, concrete temperature increases or decreases by about 1 degree Celsius for every 10 kilogram per meter cube. Concrete temperature increases or decreases by about 1 degree Celsius for every 10 kilogram of cement, 10 kilogram per cubic meter of cement. Increase in cement content, substantial increase in cement content determined as a result of verification concerning thermal stresses and thermal cracking must be avoided. A substantial increase in the cement content determined as a result of verification concerning thermal stress and thermal cracking must be avoided. If, however, it is difficult to achieve required workability, strength, durability, workability, strength, durability, water tightness, cracking resistance of steel, protection, performance with cement content specified at design stage. It may be necessary to reconsider cement content if type of cement or admixture be used is changed. It is necessary to perform verification concerning thermal stress and thermal cracking again and again. Okay, rate of heat generation of concrete is roughly proportional to cement content. If you increase 10 kg per cubic meter, there may expected 1 degree Celsius rise in concrete temperature. And a substantial increase in cement content determined as a result of verification concerning thermal stress and thermal cracking must be avoided. If, however, it is difficult to achieve required workability, strength, durability, water tightness, cracking resistance, or steel protection performance with cement content specified at design stage, it may be necessary to reconsider cement content if type of cement and mixture to be used is changed. It's necessary to perform verification communal If, however, it is difficult to achieve required workability, strength, durability, or tightness, cracking resistance is steel, or steel protection performance with cement content specified at design stage, it may be necessary to reconsider cement content if type of cement or admixture to be used is changed. It is necessary to perform verification concerning thermal stress and thermal cracking again and again determine cement content or binder content if not cement binder is used. Non-cement binder is used. That doesn't cause any problem associated with thermal cracking. Mass concrete shall be produced taking into consideration such factors as concrete transportation distance, transportation methods, placing methods, weather conditions and other conditions so that placing temperature does not exceed specified limit. Mass concrete shall be produced taking into consideration factors such as concrete transportation distance, transportation methods, placing methods, weather conditions and other conditions so that placing temperature does not exceed a specified limit. Lowering concrete placing temperature is effective in thermal stress. Lowering concrete placing temperature is effective in thermal stress. Lowering concrete placement temperature is effective in thermal stress and thermal cracking because doing so reduces difference between temperature in member and temperature outside member, lowers highest temperature in member. One method of lowering temperature is pre-cooling, in which ingredients such as water and aggregate are cooled in advance when concrete is produced. Effect of temperature in each material on as mixed concrete. Let's do. So lowering concrete placing temperature is effective in thermal stress and thermal cracking because doing so reduces difference between temperature in the member and temperature outside member and lower. Highest temperature in member, one method of lowering placing temperature is pre-cooling. Ingredients such as water and aggregate are cooled in advance when concrete is produced. Effect of temperature in each material on as mixed template of concrete is as follows. Effect of temperature of each material on as mixed temperature of concrete is follows. Change of plus minus 2 degrees in aggregate temperature, resulting in change of plus minus 1 degree Celsius as mixed temperature. Change of change of plus minus 4 degrees Celsius in water temperature, resulting in we have to think of this. Means 2 degrees or 4 degrees, you can say a change of 4 degrees in water temperature, resulting in change of plus minus 1 degree Celsius, and change of plus minus 8 degrees in temperature, resulting at plus minus 1 degree Celsius. It's very, very important point here to note. Lowering concrete, what says lowering concrete placing temperature is effective in thermal stress and thermal cracking, because doing so reduces difference between temperature of member and temperature outside member, and lowers highest temperature in member. One method is placing temperature pre-coolant. Water and aggregates can be pre-cooled. Effect of temperature in each member, each material on as mixed temperature of concrete is change, that is change of plus minus 2 degrees in aggregate temperature, results in change of plus minus 1 degree Celsius in mixed temperature. Change of plus minus 4 degrees Celsius in water temperature, resulting in change of plus minus 1 degree Celsius. And a change of plus minus 8 degrees Celsius cement temperature, results in plus minus 8 degrees Celsius. Pre-cooling methods include a method that uses cold water, a method that uses flake ice or small ice fragments independently or in combination of part of mixing water. A method that uses cooled aggregate, and a method that cools materials or concrete by using liquid nitrogen. If small ice fragments are used as part of mixing water, it must be ascertained that before placement of concrete that ice has completely melted. If liquid nitrogen is used for cooling, care needs to be taken to ensure safety, particularly in control of concentration of oxygen. If liquid nitrogen is used for cooling, care needs to be taken to ensure safety, particularly in control of concentration of oxygen and around the place where liquid nitrogen is used. Even if temperature of concrete at time of production is lowered, concrete temperature may rise during transportation, so that placing temperature becomes higher than expected at planning stage. It's important to determine temperature of concrete at time of production, taking into account likely amount of rise in concrete temperature. So we can say, even if the temperature of concrete at time of production is lowered, concrete temperature may rise during transportation. So placing temperature becomes higher than expected at planning stage. It's important therefore to determine temperature of concrete at time of production. At time of production, taking into account likely amount of rise in concrete temperature. Due to such factors as transportation, distance, transportation methods, and weather conditions. Construction, partitioning into blocks, lift height, and joints. In placing mass concrete, size of blocks, height of lift, location and structures of joints, and interval between successive castings should be decided based on result of thermal verification. Signals are again 0, 0. What to do? This is a game of signals. We have to play game of signals like we are talking of concrete temperature, and this is concrete temperature, a signals temperature, you can say. 0, 0, 0, 0. What to do? Everything is 0. I don't know what to do. Means I don't know. I speak or don't speak. We'll have to wait for a couple of minutes, couple of seconds, not minutes. It's fine. If it doesn't work, what to do? I can't rely upon now because I don't have 0, 0, 0, 0, 0, 0. Nothing is increasing. 0, 0, 0. 0 is a video bit rate, 0 is frame rate, and 0 is audio bit rate. All are 0. Something has come, very little. Let us do something is better than nothing. In mass concrete, large volume of concrete is placed in many areas of blocks which are separated by joints. Location and structural details of joints, as well as size of blocks or dimension of horizontal and vertical partitioning, needs to be determined with comprehensive consideration of heat, dissemination or dissipation, and resulting conditions, as well as various construction conditions, one of which is concrete placing capacity of each member each time. The mass concrete is placed into blocks, partitioned vertically. When mass concrete is placed into blocks pertaining vertically into lifts divided horizontally, stresses will develop with variation of temperature of concrete structure, because an evenly placed concrete is restrained by previously placed one. Stresses grow larger when differences in effective Young modulus as well as in temperature between new and old concrete increase. Concrete placing time interval should be kept as short as possible. However, where concrete is placed lift by lift on such bodies as rock bed, which provide significant restraint to short place intervals, may result in high temperature in mass concrete and consequently high potential of crack development. As a result, placing interval at constant size shall be determined with due considerations together with other measures to deal with development of thermal stress. I repeat this. These stresses grow larger when difference in effective Young modulus as well as in temperature between new and old concrete. Therefore, concrete placing time interval should be kept as short as possible. concrete placing time interval should be kept as short as possible. However, concrete is still placed left by left on which such bodies as rock bed, which provides significant strength to short placing intervals, may result in high temperature in mass concrete and consequently high potential of crack development. Placing interval at construction site shall be determined with due consideration. Placing. Placing temperature of mass concrete. Placing temperature of mass concrete shall not exceed plant temperature. Placing temperature of mass concrete shall not exceed plant temperature during placing process. Temperature of concrete shall be measured. Temperature of concrete shall be measured. Thermal history of placed concrete shall be monitored, and plan for construction may be changed if required. Placing temperature of mass concrete shall not exceed plant temperature. During placing concrete, temperature of concrete shall be measured. Thermal history as placed concrete shall be monitored, and plan for construction may be changed. Verification. So, placing temperature of mass concrete shall not exceed plant temperature during placing. Temperature of concrete shall be measured. Thermal history of placed concrete shall be monitored, and plan for construction may be changed accordingly. Verification method for placing temperature of mass concrete is included in verification of thermal crack. One must keep in mind that assumed conditions at design stage of thermal characteristics of materials and environmental conditions may differ from those at construction site, at construction stage. That is what it says. One must keep in mind that assumed conditions at design stage of thermal characteristics of material and environmental conditions may differ from those at construction stage, from those of mass concrete prevention, those of there's a construction stage when actual placing temperature exceeds assumed placing temperature of mass concrete, prevention of thermal cracking, as well as cause or control of crack. Verification method of placing temperature of mass concrete is included in verification of thermal crack. One must keep in mind that assumed conditions of design stage of thermal stresses, thermal characteristics of materials and environment. Conditions may differ from those at construction stage when actual placing temperature exceeds assumed placing temperature of mass concrete. Prevention of thermal cracking as well as control of crack width may become difficult. As a result, desired function performance may not be satisfied. Therefore, concrete temperature and temperature rise of placed concrete should be confirmed at time of construction. Construction plans should be modified if actual condition is too much different from assumed one, especially when placing concrete under scorching sun. Special cares on management of materials, concrete. Concrete production, transportation, placing, etc. shall be applied to make sure that actual placing temperature shall not exceed plant 1. Since exothermic properties of Portland blast furnaces lag. Cement is accelerated if temperature is 40 degrees Celsius. Let's say against that temperature rise in place concrete should be confirmed at time of construction. Construction plan should be modified if actual condition is too much different from assumed one, especially when placing concrete under scorching sun. Special care on management of materials, concrete production, transportation, placing shall be applied to make sure that actual placing temperature shall not exceed planned one. Since exothermic properties of Portland blast furnace like cement is accelerated if temperature is high, placing temperature should be as low as possible in order to control temperature. Curing mass concrete, appropriate care shall be taken to control concrete temperature so that thermal cracks can be controlled per plan. In curing of mass concrete, adequate measures for thermal crack control based on results of In curing of mass concrete, adequate measures for thermal crack control based on results of verification and curing methods specified in the construction plans need be taken additionally with conditions required for curing of normal concrete. Especially, it is necessary to apply appropriate measures to cool down concrete temperature as close to ambient air temperature as possible. To keep temperature difference between close to ambient temperature as possible, to keep temperature difference between interior and exterior of concrete member as low as possible, and to maintain temperature drop rate of whole member at acceptable level. If necessary, such measures as thermal insulation and protection of concrete surface with adiabatic materials. Adiabatic materials, that is styrene or sheet. Adiabatic implemented. Sprinkle more water that necessary lead to formation of cracks can say by decrease in number of we're talking of something very important here, that is curing of massive block. It is based on very important factors actually. It's not as I was thinking, it's very important one, curing of. Generally we say, so we do this curing, thermal curing, this, we have to understand every point as we said in this paragraph. Again I read for you because it's important one, curing of mass concrete. Says curing of mass concrete, adequate measures for thermal crack control based on results of verification and curing methods specified in construction plans may be taken additionally with conditions required for curing of normal concrete. Specifically, it is necessary to apply appropriate measures to cool down concrete temperatures as close as possible, means internal as well as external temperature of member, keep temperature difference between interior and exterior of concrete member as low as possible, and to maintain temperature drop rate of whole member at acceptable level. If necessary, such measures we have to keep this mind now. I'll be here for maybe a couple of minutes before we do it, and I think we should take some time to study. It's very important point. It's very important part actually. We have to be little understandable of this.